This is Palmer, your AI office worker desktop assistant. Palmer learns about your company by ingesting large folders of information of your company. From there, you can ask questions, create memos, PowerPoint presentations, create Python code, and more. In this example, we'll showcase Palmer working with the data of a fictitious electric vehicle company, Voltage Motors. As you can see, it has a complex folder structure with everything from engineering to sales to HR. The folders all contain subfolders and files. Palmer's first step to working with you is to ingest this data into his internal RAG database. We will also quickly tell Palmer about our company and what we do. After quickly saying hi, let's do our folder ingestion so Palmer can learn about the company. Great. Now that Palmer is up to speed, let's ask some questions. What are our best-selling products and market? By intelligently searching through right contexts, Palmer will give us the answer. He will also provide a list of file references or sources so we can double-check. Let's now create a memo based on this information. We'll tell Palmer to address it to the marketing team and that it should be an email draft. Palmer successfully creates the file and tells us where he saved it. We can open Palmer's workspace folder to see where his work goes. Inspecting the file, we see that we have a nice email draft with the requested information, ready for us to use. Let's write some code. Palmer lets us quickly create, run, and edit programs straight from the chat interface. Let's make a Python program for a scatter graph of data from 2 columns in a pandas data frame, perhaps preparing us to handle some data analysis task. The program file is created and we see its location. Now we can simply ask Palmer to run the program. Next, we'll ask Palmer to edit our code so that we include a line of best fit and the R² value, and we'll put this information in the title. We run the program again and we got it. One can see how we can quickly and easily develop useful software for our work using Palmer. Next, let's look at how we can create PowerPoint presentations. While they won't be pretty just yet, Palmer will create for us solid content that will serve as a starting point for the topic at hand. In this example, we are making an HR presentation to help onboard sales employees for our new, fictitious India locations. Once he's done, we ask Palmer to open the file and see that we have a full presentation with many relevant points for our topic. Now we can ask Palmer to edit our presentation. Let's ask him to include a few slides about what makes our company unique and how we will compete in the Indian market. We open the file again and see that the extra content has been created. After some edits and styling, our presentation will be ready to go. This next example will further demonstrate Palmer's capabilities when it comes to creating files based on company context. In this case, we'll make a presentation lecture on semiconductors based on the first chapter of a textbook in our company folder. We open the file and see that we get pretty good coverage. Now, for something cool, let's edit the presentation such that Palmer is to add a prompt to every slide in square brackets that will generate an appropriate DALL-E image. This is a first look at multimedia content creation that will be possible relatively soon. Here's another example of creating a memo based on the context of what our company does. Palmer is instructed to draft a memo to the software engineering team regarding features, requirements, UI, and architecture for the new Voltage mobile app. This requires some creativity and background knowledge. Opening the memo, we see that Palmer delivers quite well. Now we can further edit the memo, asking for a few key points on app performance metrics, added to the end of the memo. From the raw drafts that Palmer creates, we get an idea of how useful of a brainstorming buddy he is and how much time we can save. Now let's take a look at the internals of how Palmer works. In the terminal on the right, we can see some debug messages, for example, the chat history with the user. Firstly, every time Palmer receives a message, he first chooses from a list of predefined actions to decide what to do. Examples include regular chat, such as this example, and we can see his internal reasoning. If Palmer receives a more involved message, he will call Chat with Context, a function that knows to use our RAG company database to get more info. Similarly, Palmer can choose to make a Python program, and he will fill out the arguments internally of what to name the script and what text to put in it. Asking him to run a Python program will get him to choose the Run Python function, and similar for opening a file. Using this function-based methodology, Palmer can interact with and control the user's computer to accomplish many useful tasks. When company data gets updated, we have a simple and efficient way to update the RAG database. Essentially, the folder is re-ingested, but only files modified since the last ingestion have their database contents updated. Right now, the user is to do this manually, but it's simple to extend this to a periodically occurring update. As we see, only the modified file is re-ingested. Asking Palmer something relevant to this file shows that he accurately retrieves the updated information. Finally, let's take a look at Palmer's internal data. The Inspect Palmer DB button shows relevant tables such as a full user chat history, the company metadata, the files created by Palmer, and the RAG database hierarchical structure. We store company data in a hierarchy because internally, Palmer is doing a type of beam search. Based on the query, he checks the top N most relevant folders for the top M most relevant files, where he grabs the top P most relevant text chunks. Contexts are folders. Every folder has a description based on its internal contents, generated hierarchically bottom-up. Every description has an embedding, the foundation of the RAG beam search. Every file encountered is broken up into fragments of the raw text data, each with its own embedding. Every file also has its own description and description embedding. We use an interesting recursive summarization approach to summarize large files, whereby we generate a list of fragment summaries, group those summaries and summarize them, and repeat this process a logarithmic amount of times until we get a final summary that fits inside a modern LLM context length. The point of this hierarchical RAG infrastructure is to make context search a much more efficient process.